ecosystem at Huawei Incorporation. He has 25 years of work experience in networking and software architecture. He currently is TSC member for FT.io and Open Daylight. He is a board member, he's a board of directors silver representative for DPDK as well. George received a bachelor in electrical engineering from McGill University and master's in computer engineering from the University of Toronto. So without any further delay, let's invite Mr. George with a huge round of applause to come and enlighten us. Thank you.
Thank you, Swam. Hello, I think Swam introduced me pretty well. My name is George Zhao, and I'm a silver representative as a DPDK board of directors, and currently as TSC member for FIDO. I believe I'm the last topic here. How do you feel after 15 sessions staying here? Well, I arrived this morning at 3 a.m., so I know what you feel. I really like to take these opportunities to thank people like Sujita, Kanan, Jason, Monsu, so a lot of people put this together. A very successful DPDK Summit. This is the first DPDK Summit in 2018, and it's a wonderful start. Okay, go back to my session. So first one, I would like to do a brief introduction for FIDO, and then I'll mention the challenges and for the current cloud applications. At last, I would like to propose the solution for it. So how many people here know familiar with FIDO? Okay, quite a lot. For those who don't know, FIDO is actually an upstream project of DPDK. It's also open source. It's doing high throughput, low latency, focus on the fast I/O packaging forwarding. Just look at this. It's actually, I like these marketing terms, but it's also true in certain sense. Oh, the laser prompt doesn't work. But anyway, so it's the most efficient on the planet. So basically, the flagship project in FIDO called VPP, Vector Packet Processor. So it processes packet one vector at the same time. So it's reached a lot of efficiency and achieved the superior performance. Flexible, they have a project called Honeycomb, which is an interface with the SDN controller. So it can be model-driven. And also you can customize it as well. So it's based on SDN, it's cloud native. It's building the foundation for the cloud. And as I mentioned, it's open source. It achieved 1 terabit service on the single Intel Xeon server. Very good, very fast. This is just another angle to look at the FIDO. The FIDO community basically consists as a network I/O, packaging process, and the data plane management agent, the 3-part. And it's actually suitable for multiple hardware platforms like Intel x86, ARM, PowerPC. So as I said, the flagship project VPP is actually in production since 2004, so has been proven technology in the industry. FIDO, if you look at the logo here, they have actually a small text under it, the universal data plane. It is actually true because it can be deployed on a device. It can be, I hope this, okay. It also can be in the smart NIC. It can be deployed on the server. And it also can be deployed on VM or container to build your NFVI. So it's actually one data plane. You can deploy it almost everywhere. So that's enough introduction for FIDO. Let's go back to what we talked about, why we need a framework for stack, protocol stack. So for cloud application, actually a lot of speakers also mentioned we have stacks on the kernel space and the user space. So cloud applications actually, they have to, if they keep on swapping from database, user space and the kernel space, the performance will downgrade. So what to do? So one solution is move everything to user space. I know some people may not agree. To move to the user space, to make it to avoid the swap from kernel space and the user space, but will allow normally user space and kernel space, they have different APIs. Then the application has to need to adopt to different APIs based on that. So that's the first challenge we face. Also, different applications may have different requirement as well. Some may have high throughput, like file transfer. Some may just want low latency, video on demand, or like an online game, live stream, you want low latency. So different apps have different flavors. So how do we address it? I can think about it as like I have different algorithm to build the build stack to suitable for different applications. I can use a file transfer one for the file transfer for high throughput, or I use a low latency stack for online game, and the rest I just use kernel TCP/IP to do the stack transfer. Well, can application to choose this dynamically? So that's another challenge we're facing. And also we know hardware are not built as the same. Hardware has different capabilities. We just use RDMA as may not be a good example, but one thing to show the idea. You need both ends to have RDMA capabilities to leverage these fantastic technologies. So how does the application know what underneath hardware capability, and dynamically select a protocol stack best suited for its use? So that's the three challenges we're facing. What is our proposal? So we call it a DMM. DMM stands for dual mode, which is a user mode and kernel mode. Multiple protocol, the first M multiple protocols, so we can support different protocols and multiple instances. So different applications can have multiple instances, or even same application can have multiple instances running inside this framework. So DMM is a framework to try to achieve dual mode multiple protocol, just as the name stands for, multiple instances. It's actually a project chartered in FIDO, and the first release is going to be targeted next month, 1804. Is Pasar here still? Yeah, okay, yes. Pasar and his team in Bangalore office actually is developing and doing this. Thank you so much. I will redirect all the questions to you. So this is the architecture, the high-level architecture of what DMM is. On the northbound, we have a POSIX socket API, which is the same to both user mode or kernel mode applications. So application doesn't have to deal with different APIs. On the right-hand side, we have a resource discovery, and it basically talks to the protocol orchestrator. So that will actually basically, at runtime, based on your policy, your QoS or your configuration and your policy to determine which is the best stack, the best stack to use inside this framework. So in the southbound, we have a hardware abstraction layer, which is provide the common interface to all the hardwares. So we can support on this side. We have user space. The stack listed here in yellow color is already existing in FIDO. So like a VPP host stack is developed by Cisco. TLDK is by Intel. F-stack is new, it's by Tencent, but we want to introducing it, bring it in the FIDO as well. And we also, of course, we have kernel space at TCP/IP. So if you look at the down, the green one is the framework of DMM. Yellow one is existing project or existing code in the FIDO. Honeycomb is actually ported. Honeycomb actually initially is developing Open Daylight, and then we ported to FIDO. It's actually should consider as a FIDO project now. And we have third party, which is the F-stack. And I already introducing the northbound proxy socket at northbound and also the pocket orchestrator. Gee, I talk fast. I give you a few minutes back so we can, hopefully you can catch the traffic for the bungalow. I know, I heard it's pretty bad. Key takeaways. So what's the advantage of this framework, DMM, we give? First one, we can allow the stack developers just concentrate on, they develop different algorithm of stacks. In here, you can just plug in this framework. You can concentrate, as I said, different applications has different need. You can have different algorithm for high throughput, low latency, or whatever your app is concentrated for. You can just plug in this one instead of worry about all the hardware abstraction layer or the northbound by being configured and controlled. Second, we give application the advantage you can dynamically select which protocol stack is the best for you. You can based on your QoS, it can based on your configuration or policies. Second, this is actually for build for the container network. It's easier to build end-to-end communication capabilities. That's the key takeaways for this DMM. Oh, that's the last page. I add a thank you page, but it doesn't show up. So I guess this is the early version. Okay, so questions?
You said that we can select which stack to use based on a SDN controller, right? Which stack to use, yes. So I'm reading that second point there on the bottom right.
Okay.
Right. So one quick question is, you do that before the transactions or before the connections have to be established, or is it a runtime thing where given connections can be shifted from stack to stack based on rules that SDN controller pushes?
That's a very good question. Actually, I think the first, it can be SDN controller is basically from these two interfaces. Honeycomb, we know, is basically talk to the SDN controller. The resource discovery can be connect to the SDN controller or basically just the orchestrator, like a Kubernetes master directed to it. Initially, we just do at the configuration time. So when you set up the configuration, it depends on the use case, whether there is a use case to do it dynamically. So if it is, then we need to make it possible. But at this time, we're not really target on it. We basically just target on the configuration time.
Okay, so why I asked was, as you said, use case. So for example, if a given stack has been deployed in a data center, I can segregate the traffic based on costing.
Okay.
So my costing, when the user is ready to pay higher, I can transfer those costs using faster DPDK or LDK stacks, TLDK stacks, else I can transfer using the TCP IP stacks. So, but then I understand it's not, it's just static right now.
Perfect. That's actually excellent. You answered the question. You raised the question, you answered. Actually, that's very great. So initially, we think we do it at the configuration time. It can be, as I said, can be orchestrator, and you mentioned it can be done at the runtime. Your policy change, and then you set another controller to set up, and whether we can do it at the runtime to switch the stack. I think we should be able to do it, but not sure at this time we have done it or not. But that's a very good question. I will thought it more and with our development team on that as well.
How do you do the network interface binding? Basically, like if you have a NIC card which is not SRI UV capable, right? You just have the PF available to you. Then how do you bind the Linux stack along with the DPDK driver on the same PF on the NIC card?
I cannot go to that detailed technical level, but initially, actually, we basically, the first stage, we just bound to DPDK directly. So we don't have all layers. The stack basically goes to the DPDK directly, and then that's in the 1804, which we're going to release next month. And then after, we're going to introducing the integration with VPP host, the TLDK, and the VPP inside it. It's actually the next stage. So the initial stage, we just bound to DPDK, use it the same way as everything else.
Hey. Hi, thank you for sharing. I have one doubt with regard to the NIC PMD part and interface from the stack.
Okay.
Let's say I have stack 1, 2, 3, which has this order of precedence as 1, 2, 3. Each of these guys can put the packet through NIC interface 1. Okay?
Okay.
Now, in DPDK Polymer driver, as far as I remember, unless you use the TM APIs, which is recently released, there is no way of guaranteeing which packet is going to be sent first, because the Polymer driver, whatever it inserts, that is the order of the priority. So if the 3 stacks are going to insert in a lockless mode to the PMD, the priority or the packet arrangement would change. Would that affect the performance?
Okay, that's a very good question, and I won't be able to answer you that question right now. Let's talk offline, and I will hook up our dev teams and see how we address that one. DMM basically is actually a project developed inside Huawei, so we must have a way to achieve that, and we just open source it and put it into contribute to FIDO 1. So it's not like developed from scratch. It's been there, exists there for a while, and we already tested. And also we also have a plan to commercial productize it. So we can talk. I can keep your information on that definitely.
We'll take one last question.
You have planned to support OpenFlow for the SDN2 program?
Not in the roadmap at this time.
Even FIDO doesn't support OpenFlow at this point.
I won't say yes or no, but right now it's not in the roadmap, in the DMM development plan.
Even for FIDO, right, like what is the way to program externally? Like, is it so from an external way? Like, what is the model in which we have to program FIDO? Like, is it only REST?
Northbound FIDO, pretty much REST, yes.
Only REST is supported.
But you can do also.
How does I know like OpenFlow is not supported?
Good question. I think OpenFlow, if on the northbound level, it should support it because it doesn't know at this time. At the transport layer, it doesn't know the differences. But for DMM, I can just say it's not in the roadmap yet, as far as I know.
Yeah, so like at least for the FDIO, like we were looking as like a obvious alternative to use that for getting higher performance. So thing
you can think it as FIDO. You can think it as an alternative as
to
OVS.
Yeah, but the thing which which stopped us from using it is it didn't have OpenFlow support. At least I couldn't find.
That's actually a long discussion of that.
Okay.
I know we have actually FIDO OVS. It's a long discussion.
Okay.
And I don't want to answer either way or one way or the other.
Okay.
So let's do that in the offline.
Okay, sure. Thanks.
Thank you.
Yeah, it was a wonderful talk, Mr. George. Thank you so much, and let's give him a huge round of applause.
Thank you.
Thank you.